everybody, in this video what I'm going to do is I'm going to walk through the problems on quiz 8, showing you how to get set up for each and every single one, 1 through 13, on quiz 8, fall 2020 edition. Let's start with the first one on quiz 8 and see if we can get a plan of attack. I've already transcribed the assumptions. So let's see what we got here. We got squiggle F, wedge squiggle G, H wedge, I wedge F dot G, and we've got G arrow squiggle H, and we're going after J arrow I. Now I want you to notice here, here's what it says. It says that this can be done in 8 lines or fewer with a recommended last step of hypothetical syllogism. So with that in play, take a look what you've got here. We're going to get, take a look at what your goal is. Remember, that's the first thing to do. Take a look at your goal, and look, we've got J arrow I, and it says you can get it last move of a hypothetical syllogism. What would you need? What 2 things would you need to make a hypothetical syllogism to get this? Well, you would need J arrow something, and you would need something arrow I. We don't know what the something is. However, I'll say this already, in the proof, line 3 is J arrow squiggle H. So in all likelihood, the question mark that I was doing over here is probably the squiggle H. Okay, probably. It's possible that it's something else, but this is looking very likely here, that once you get these 2 things, of which you already have one of them, so you're good to go. So really what this problem is about is finding, can we get a squiggle H arrow I? I'll say that's a good thing to look for in this problem. Look for how to get this. Okay, now when it comes to so this is the first plan. Okay, take a look at what your goal is and see what would I need to get this based on the recommendation. And you can be done by line 8. So what are some things that I'd want to do here? Well, so first of all, we looked at the goal. Distribution. Not happening. Okay, advanced rules. Okay, is there anything where we could do, like start with conversions? There's nothing here with squiggles on the outside where I see that that's necessary right now. So I'm not going to do any conversions, but then I move on to the other advanced rules on the list. There's one that I do see that's obvious that I'd want to do here. All right, to make things more useful. It might not be obvious to spot that you can do it, but I want to say it focuses on line 2 here. So this line 2, I'm actually going to take this out to show you how to start here and what will make this problem, I think, work a little bit more easily for you. So let's take a look at that line 2, and I think that's going to make things easier here once we see what's actually going on here. Take a look. We've got H wedge I wedge F dot G. Okay, so there's actually one of those advanced rules we can do to this right now that makes this much easier to work with. It might not be super obvious. So let me actually just write to the side here what's going on in this line, and then maybe we could see it. So look, we have something, wedge, and then a heavy right of wedges, something or something else, with parentheses around the right side. So look, A corresponds to H here, B corresponds to I. The FNG is just the third thing put together with ORs. Now there's more stuff going on here, so it looks a little extra complicated, but it's actually the same thing as this. So what does that mean that we can do? We can move the parentheses with the law of associativity, or with the associative property here. That would get us A wedge, B wedge C. Now it doesn't change the meaning of this, but you'll see that it makes it easier to work with. So if we did this move here on this, what would that look like? Just because there's these brackets, because this goes deeper, what would this look like? Well, I'm going to go ahead and tell you what it looks like. Move the parentheses over, make this look like this, would mean we get this. We'd get H wedge I, or the third part would just stay over there by itself like it does over here. Okay, the third part just happens to be bigger. F dot G. So if on line 2 we did, that would be the law of associativity. We get this. This is much easier to work with. So I'm going to say that really one of the first things you should do, if not the first thing you should do in this problem, is this, because anything where you've got a bunch of ors like this is going to be much harder to get things done. This is going to make things a lot easier for you because I'll just say this. Now, if you go down the list again, you'll see going down that list, okay, looking at the goal still. Remember going after squiggle H, arrow I. Well, look, if I could get this out of there, if I could get this H wedge I, and I did a material implication on it, what would material implication on this left side look like? Oh, it kind of looked like squiggle H, arrow I. So if I could get there, if I can get that out, so I want to look for strategies to get this out. So here I'm going into a lot of detail to give you a plan of attack, but that's the way I want you to look at all these problems. All these problems are approachable. We've got a goal that you can get. I've told you the lines in which you're able to get it, and the final move here. So once you know that, you can make a plan of attack for how to get to the end. Okay, what you really should be looking for. Make yourself little goals along the way. Let's take a look at the next problem, number 2, and get you set up for that one. All right, let's look at number 2 to get set up on this one. So we've got squiggle W, X, XOR Y, arrow Z, and we've got W, XOR X, XOR Y. What do we do? And look, you can be done by line 6. That means really you've only got 3 things to do, 4, 5, and 6. And you know what the last thing is going to be. It's going to be your goal. So really, this problem is just fill in the blanks, see what you need to do here, see what you need to do here, and fill in the 3 right columns. Here's what's done. And actually, the last move can be an arrow out. So I honestly know I can stick this here. Arrow out, something. It's still question mark, comma, question mark. We don't know where the arrow out is going to come from, but you could go ahead and stick that arrow out there at this point. And then, since you know it's going to be an arrow out, one of the things that you know is the way arrow out works. Think about it. Arrow out works this way. This is something that we've done since quiz 2. Get A, arrow B, get a left side match, then you can get the right side. So that's true, and we can get Z in an arrow out. We know there's going to be some arrow where Z is going to be on the left side, and we're going to get Z out. That's going to happen. Do we know what the left side's going to be? Maybe, maybe not. But look, we already have an arrow with Z in it. Z on the right side. So if we got this left side, a match for it, which looks like the pieces are here, we just got to figure out the means to get it, you're good to go. So there's your plan of attack. You know what you need to get. You need to find out what's the left side of the arrow. It looks like it's going to be here. Just going to write it over my question mark. X or Y, and then X or Y again. It looks like if I could find these, which this one checks out, I've already got it. If I could find this, bam, I got Z. I'm good to go. Do I have that X or Y by itself? No, it's hiding in here somewhere. Look and see, are there ways to move things around going down that list? Can I do distribution? Can I do any of the other advanced rules? Can I do basic rules to make this happen this quickly? Let's take a look at the third one. All right, now we're set up for doing the third one here. So first things first, look at what your goal is. You're going to get T.S. That's the mission. It can be done in 7 lines or fewer with the final move of the law of commutativity. Now, what does commutativity look like? That's where you take a dot, a wedge, or an XOR, and you can just take the 2 sides and flip them back and forth. So that means if the last move is going to be commutativity, before you had T.S, we're going to want to get S.T. That's the mission. Do I see that anywhere over here? Yeah, look, it's on the right side of this arrow. So a good idea here, then, if we want to get S.T, and there it is, right here, then maybe, this is it's on the right side of an arrow, the left side is R, it might be a good idea to go after R. See if you could get, because if you got R, and I see some other R's floating around here, if you got R, bam, that would just unlock the right side by line 7. So that's a good plan of attack for this one. Let's take a look at 4. Number 4. All right, first thing, look at the goal. It's C arrow, squiggle D arrow, squiggle Z. Now you might notice, it's an arrow. I can do an arrow in. You could, but notice that what it says here is that you can be done by line 12 or fewer with a final move of exportation. That's what XP is. So let's review that rule real quick. So look at what we've got. Exportation works this way. Now this is a rule of substitution, which means it's a vice versa. It says, the way I have it in your advanced rule sheet, if you've got this, you can then turn it into this and vice versa. Okay. So what are we starting with? Are we starting with version 1 or version 2? So we got an arrow. Basically, do you have an arrow where the left side of the arrow is a heavy left that is a conjunction? Or do you have an arrow where the right side of the arrow is a heavy right with itself an arrow? Which do you have? Right? Do we have this version or this version? We have version 2. Okay, so we've got this. So what we need to do is plug these values back into this. So what's going on here is C is corresponding to A, squiggle D is corresponding to B, and squiggle Z is corresponding to C. If that's the case, what would we need to get here? Well, we're going to figure out what line 11 is. Because if line 12 is going to be this, with exportation on line 11, then the thing before that would be whatever this would be. So let's see what that would look like. We are going to need to get, really then, in line 11, C dot squiggle D, close, arrow, squiggle Z. This is really what you want to get. If you get this, you're good to go. Okay, so this is really what you're after. Now, furthermore, let's go down the list next. We've identified our goal and what we have to do to get it. So really, you need to get this first. Now, are there things that we'd want to do otherwise? So can we do distributivity? That'd be the next thing we want to look for. No, that doesn't look like it's happening. Is there anything whereby we could do a conversion on it, and it'd be especially useful if it would get rid of a negation on the outside and make it easier to use? Well, look, here is a wedge with a negation on the outside. I would recommend doing a conversion here, and I think you'll see that once you figure out which conversion is appropriate, and you're going to be able to do some things that lead you to here, which let you get to this final move right here. All right, plan of attack for number 5. We're going after B. Okay, and look, the last move is a disjunctive syllogism. So remember, there's 3 disjunctive syllogism scenarios. Okay, there's the one that looks like this. Okay, where with a disjunction, if it's inclusive, and you have not one of them. Okay, so if I said squiggle A, then we'd know, hey, we've got B. Also, if I said squiggle B, well, then we know A. Because we've got to have at least one of them. You could have both, but we know if we don't have one, we definitely have the other one. Now, this inclusive disjunction only works with the negation saying not one of them. Exclusive disjunction works either way. Okay? So if you get exclusive disjunction, I could say I have A, well, then I know I don't have B. But it also works just like inclusive disjunction as well. If I say, well, I don't have A, well, then I know I have B. And I could pick the other letter. I could start with B instead, and then I know not A. Or I could start with not B, and then I'd know I'd have A. So these are all the possible disjunctive syllogism scenarios. So here's why that's important. Take a look at what I actually have in this problem right in front of me. I know I'm going to get B. I know that the last move is going to be a disjunctive syllogism, and I can be done by line 12. And I'm going to get B. Look, I already have in line 1 A, X, or B. Now, this gives me a hint that at some point, really what I want to look for in this whole problem, it's really a mission to get, for right now, in the meantime, line 11 is probably going to be squiggle A. So really, that's the mission. Do you see another A hiding in here somewhere? Yep, right there. So maybe we can get an A out of here somewhere. Let's see what we can do. See if we can get some kind of squiggle A out of this. I will say it is possible. So that's what you want to look for. So then knowing that now, knowing that we're going to use this definitely in line 12 of the problem, it's going to say something. It's probably going to be disjunctive syllogism, probably line 1 and line 11. We just need to figure out how do we get there the rest of the way. Okay, so then look around. I mean, can you do any distributivity? That's not a thing happening right now. Are there anything that we could any conversions that we could make And so you want to look for are there conversions that you could make where they'd be useful in the meantime to get rid of squiggles on the outside. I don't see any of these squiggles on the outside. Like there's one here, but I don't want you doing De Morgan's law and conjunctive conditionality and material implication inside pieces. I want you to be able to do it on the whole thing. So here, is there anything that I'd recommend doing? Now, if it doesn't look like there's any squiggles on the outside, another thing you can look for is if I made a conversion, would allow me to do an arrow out or modus tollens especially. And I'll just say this, right now there is a conversion that would totally allow you to do a modus tollens. And so look for, do I have anything where if I did a quick conversion, I could do an arrow out or a modus tollens. I'll just say that is available right now. And look and see where it is. But it is available. One of those conversions would work here. So I'll get you set up for this one. Let's take a look at the next one. All right, let's get a plan of attack for number 6. Remember, first thing to do, look at the goal. All right, we've got x arrow z.w, and we've got our assumptions here. X wedge, squiggle x dot y. We've also got x arrow z. Those are our assumptions, and we're trying to get this thing. And now you might think, it's an arrow. I can do an arrow in. You can. This problem is doable that way. But look, you can actually be done by line 7. So I could actually go ahead and do this here. 3, 4, 5, 6, 7. I know I can be done here. In fact, I can go ahead and stick that in there. X arrow z dot w. And I know it's going to be dispersion. Probably on line 6, the line that came just above it. Probably what's going to happen here. So in order to figure that out, let's review what dispersion is and how it would fit in here. So if we look at the rule for dispersion, it's the last one in that advanced list of rules. It looks like this. It says if you've got this, you've got A arrow B, and you've got A arrow C, then it's a rule of substitution, so it's a vice versa. You can turn it into this. And also if you have this to start, you can turn it into that. Well, look at our goal here. Does it correspond to version 1 here? Does it correspond to version 2? It corresponds to version 2, which means basically what we're going to do here, wherever you see an A, you're going to put an X. So here's what's going on. And wherever you see a B, you're going to put a Z. And whenever you see a C, you're going to put a W. So then thinking backwards, what the rule would look like here is we're going to see this. We have X arrow Z and X arrow W. Okay. Which means this is probably going to be our line 6. Okay, dispersion on that line. Okay, so this together here, probably going to be an and in, but it could be something else. So I don't want to jump the gun just yet, so to speak. So, but let's think about this now. In order to get this, if I were going to get it with an and in, what 2 things would I need? I'd need X arrow Z and X arrow W. Do I have either one of these? Yeah, look at my second assumption. I already have half of what I need to build this. So really, what's going on in this problem is it's a quest to find this. Find X arrow W, and the whole rest of the problem just unlocks. Really, that's all you got to do. Now, notice, I don't see a single W over here anywhere. So is there a rule that lets me just bring in letters, bring in things that weren't there before? Look for that. Let's take a look at the next one. We got our assumptions up. We got our goal here. It says this can be done by line 11 with a final step of distributivity, which means we are going to look at what distribution looks like. Now, there's a couple different versions of distribution. We want to do the one that looks pertinent here. So it's the one with the wedge as a main operator. And what that looks like, LD as a rule, looks like this. You have this situation. You got A wedge B dot C. Then you can get a vice versa. That's the same thing as saying what? It's the same thing as saying A wedge B and A wedge C. Okay? So if you start with this, you can get to this. And if you start with this, you can get to this. So we'll call this one version 1 and this version 2. Okay, depending on what your starting point is here. Look, our starting point here is version 1. So basically, we're going to make it correspond. We've got Q wedge. Wherever you see A, that's going to be Q. Where you see B, that's going to be S. And where you see C, that's going to be squiggle R. Those are the things that correspond. So then we're just going to make that With those in play, we're going to fill in what this would look like over here. What that's going to look like is it's going to be Q wedge S dot Q wedge squiggle R. So that means if the last line in this problem is going to be that law of distributivity, that means this right here, this thing I just got, that is going to be probably line 10. That's the thing that I get before. So really, this proof is a quest to get this, frankly. So let's take a look and see what else I can do now. So other things that might be useful. Distributivity doesn't look like there's one that I can start with, but I know I'm going to end with it because I'm going to get this eventually. Next on the list, conversions. There's nothing really with a squiggle on the outside. Advanced rules. None that seem obvious just yet. Basic rules. I'll say this. The first most obvious thing that I see to do is actually to break down this dot. I know that seems like a simple thing to do here, but I'm going to go ahead and recommend that should be the next thing that you do, and then some other things will open up to you from there. Let's take a look at number 8. Let's take a look at number 8. Number 8 is surprisingly straightforward. We can be done by line 12 with a final move of an and in. Now, again, there was the move, all right, and in. If we're going to get s dot q, what does that mean? Well, at some point, we're going to get just s, and at some point, we're going to get just q. So really, that's the mission here. So I see an s hiding here. And look, actually, there's an and out here fairly early on. That, look, if you do an and out right here, already I can see there's the s. So really, this just becomes a mission to get q. Where is the q? Ah, the q is actually would be here with this r here, this r, x, or q. There's the only place where I spot a q. So really, I'm going to have to get the q out of there to make this work. All right, so that's possible, which means, might be on a quest to get squiggle r. Maybe, if we can find that. So really, last move is that. Now, if I'm going through, now that I know what the goal is, going down the rest, distribution doesn't look like it's necessary at all. Conversions, no. Advanced rules, really, no even. Actually, from here, it's really straightforward. Look, there's the first thing that I can see we can do, there's actually a classic arrow out here. All right, left side match, bam, get this out. Then I want to look and see, are there some conversions I could do? Go down the list again, conversions, and then see, are there some advanced rules I could do, basic rules I could do? But I could see another that and out there staring me in the face, getting me that S, which is half of what I need. So that's how to get started with this one. Let's take a look at number 9. So this one also, start with the goal. You'll see there it says that the goal is solvable within, we can get there by line 11 with the law of distributivity, which means, again, it looks like, let me pop that back up here, what that looks like. Distributivity works this way, that if you have something, there you go. If you have this is one of the possible versions of distribution, but it's the kind that matches what we've got going on here. If you've got this, then you can get this. Now, this is one of the versions of it, but it's the version, like I said, that applies here. So we're going to pump in our corresponding values here. Now, here, we're starting with this version. If I could say this is version 1 and this is version 2, we're starting with version 1. So here there's a lot of similarity between it, so let's not mix it up. Wherever in the model it's A, what do we have there? We have a squiggle A. So in the model here, B, what do we have? Squiggle B. And in the model here, we have C. Here we actually have E. It's something entirely different. Okay. And then what we're going to do, we're going to say if these correspondences are true, wherever I have A, I actually have squiggle A. Wherever I have B, I actually have squiggle B. And wherever I have C, I have E. Then we're going to do the same. We're going to do the same substitutions here. What would we get? We get squiggle A, wedge, squiggle B, and squiggle A, wedge, E. So this means, for this problem, if the last move is distributivity, really what's going on is we're getting this in line 10. Like, this is definitely going to be line 10, which means, if we look at this, look, it's the kind of distributivity where this is an and. So this is probably going to be acquired via and in, which means, really, this problem is about getting this and this. Now take a look. All right, now knowing that, take a look at the problem. Distribution anywhere? No. Conversions? Do I see anywhere where I have a squiggle on the outside where might want to turn it into something else? I'll take a look at line 1. It has a squiggle on the outside. Could I convert it into something? Well, I could turn this dot into an arrow, but that wouldn't get rid of the squiggle on the outside. What else could I do with it? I could do De Morgan's law on it, and that would get rid of the squiggle on the outside. In fact, that would give me squiggle A, wedge, squiggle B. Remember? For De Morgan's law, when you're switching from a dot to a wedge, and vice versa, you flip all 3 slots. And that would get me squiggle A, wedge, squiggle B. Hey, look at that. That's half of what I need for this. So now, based on what I've just told you, the rest of the problem becomes a quest for finding this half. So let's take a look at this one. We're going to get squiggle I wedge, squiggle Y, arrow E. So this will be done by line 8, that's pretty quick, with a final move of converse-inverse transposition. Now, how does this one work? This one says you got this. You got A, arrow B. Well, that's the same thing as saying you just you keep the arrow, switch the pieces to the either side, okay, and then you are going to completely invert whatever negations they have. So if the B didn't have one when you move it to the left, now it's going to get one. If the A didn't have one when you move to the other side, it's going to have one. So you're going to, when you switch sides, you're also going to invert whatever negations were there. So that means our goal is this. We're going to get in line 8 what we have here. The I, wedge, squiggle Y, arrow E. But what we need to do is we need to invert this, transpose it, contrapose it. And so what that means is we're going to keep the arrow, and the E over here is going to become the left side, but we're going to invert whatever its negation was, like this. And this is going to become the right side, but since it has a negation, it's going to lose it when it moves to the right, so it's going to look like this. So that means I know that in line, since I'm going to be doing this transposition here in line 8, I know my line, this is going to be my line 7. I don't know how I'm going to get it yet, but I know this is going to be my line 7. So then, now knowing what my goal is, and knowing I'm going to be here by line 7, really the rest of this becomes a matter of, well, 4, 5, and 6. What are those going to be that leads me to this line 7 that I already know I'm going to have? And then eventually to the line 8. Well, next thing on the list, can I do a distributivity? Now, so we do have a dot here, so it might seem like, oh, I can do an and out. This is a distribution staring you in the face, right here. Or technically, we'd factor out the A here, but look, we could do law of distributivity on this. In fact, you want to take a look and see what that would get you, and I think you'll find that the problem follows easily from there. Number 11. You can be done. Look, you can be done by line 4. So look, we know we can be done by line 4 with this. So we can get O with impossible antecedent. Now we don't know which 2 numbers those things are going to come from yet, but we know we can get it. So this problem's short, but don't let its simplicity keep you from the fact that the other problems are actually the same kind of methodology. This one seems less intimidating just because it has fewer lines, but it's the same kind of problem solving. So next thing to do, all right, can I do distributivity? No. Conversions, do I have any squiggles on the outside here? See if you can turn this into something else that would give you something to work with to get to impossible antecedent. That's the plan of attack for this one. Plan of attack number 12. By line 18, you can finish this off with a De Morgan's law. We'll take a look at that. If I know that this here is going to be my line 18, it's going to be De Morgan's law, then I know line 17 is I'm going to do De Morgan's law backwards. Squiggle N, wedge, squiggle T. So the mission really is find this thing, and I'm good to go. I need to find squiggle N, wedge, squiggle T. As soon as I can do that, I can do a De Morgan's law, and then this problem's good to go. Now, in terms of looking at what I've got here and getting a plan of attack, we'll take a look. Can I do any distributions? Can I apply the law of distributivity? Doesn't seem like I can do that off the bat. But take a look. Do I have any squiggles on the outside anywhere? Here. there some move I could use to get rid of this squigglage on the outside? Yeah, I could do a De Morgan's Law on this. Okay? And I think once you do that, you'll see that that opens up some other things that you can do in this problem. So that's the plan of attack for this one. Really go after this and do those. Here in this case, the first move after that would be see what conversions you can do. Finally, plan of attack for number 13. Now, number 13 is no more sophisticated than the other ones. It is longer, but it's no more sophisticated than the others. And in fact, it's a lot like number 12, actually. The last move is De Morgan's Law. Now, if that's the case, that means if my last move is De Morgan's Law, what am I going to have before this? That means in order to get this, I'm going to have at some point squiggle X and squiggle Z. And more than likely, that's going to be an and in to get there. So really, this is a mission to see if you can get squiggle X and squiggle Z by themselves and slap them together. Most likely situation there. Okay, so that, by the way, that would be 2 of these shaved off the list. That would be 21 lines that would leave left to do. Okay, consider that. Actually, I'm going to keep that there so we can maintain how much of this math is actually not you doing much at all. Now look, we got our 4 assumptions here. Well, that's actually, because those are included in the lines, that would mean really there's 17 more things to do. But then take a look at how much there is here to get started. So first of all, can we do a distributivity at the beginning? No. But here's what I want you to see. Right here, there's a squiggle on the outside, there's a squiggle on the outside, and there's a squiggle on the outside. Now, these would all require different conversions to change these, but that's 3 moves right off the bat that you can do, which means that brings us down now to 14 things to do. And then I think you'll find after you do the appropriate conversions here, these turn to things that you can just break down. So I think you'll find, in fact, that would be, by my counting, it's 6 more things to break down, which means really there's only 8 things you have to do in this problem that don't involve, let's see, yeah, that don't involve the initial breakdowns of doing conversions and then breaking down the results that you get. So really, there's far less to do in this problem than it looks like. Yeah, it's a number of lines that you have to fill out. So there's not really that much to do, even though it looks like it, because most of it is just set up to get to the stuff at the end. So again, we know we're going to do the last move is De Morgan's Law, and so really it's a quest to see how can I get here. And the setup here, the plan of attack should be, because this can look, what do I do? Where do I get started? Well, here's exactly where you get started. Get rid of these squiggles on the outside. Now, when I say that, don't just erase them. I mean, what can you convert them into that would get rid of the squiggles on the outside and give you something easier to work with? And then from there, those things break down into much simpler elements, making this problem a lot easier than it might seem just looking at it. Okay? It takes a little bit of finesse to do it in 23 lines. Getting it done in about 25 or 26 is actually pretty simple. But to get it done in 23 lines takes a little bit of finesse. You got to really take a look at your inventory of advanced rules to get that down. But that's it on quiz 8. Now, even though some of these problems are smaller, like we did one a little while ago, that was 4 lines, and this one's 23, they're all worth the same amount of points. And they all have the same features of if you can get it done within the amount of lines I said, with a recommended last move, that means you don't have to use that last move, but that's the one I'm going to recommend. I know it can be done in that many lines that way, or fewer. You get the bonus points for it, which I think makes this quiz, if you get everything just right, you don't get it in the right amount of lines, you can get 130 points. But if you get all the bonus points, I'm pretty sure that makes this quiz, you can really get as high as 195. So really, take your time on this one and try to accumulate those bonus points that will make up for any deficits that you have from earlier quizzes or that you might have here on the last 2 quizzes. So that's it on quiz 8. If you have any questions, remember, email me at thomasb@usca.edu. Next lectures coming up will be on the final quizzes, quiz 9 and 10. That's going to be on truth tables.